Finding zeros of a polynomial function. Find all the zeros of f of x equals to x cubed plus 2x squared minus 5x minus 6. My first thought when I'm trying to find all the possible zeros is to try to factor the polynomial. But if I tried to factor this 4-term polynomial by grouping, I would see that I cannot do it. So what I need to determine is all of my possible rational zeros. So the first thing I'm going to do is I'm going to list my p's over my q's. These are my possible rational zeros. So again, factors of 6 is p. Factors of 6 are 1 and 6 and 2 and 3. So I will write my factors of p, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, divided by factors of q. Your leading coefficient is q, so my leading coefficient is 1. So what are my factors of 1? Plus or minus 1. Now, what I'll need to do is go through and divide every p by every q to write out my final list of possible rational zeros. So 1 divided by 1 gives you plus or minus 1. 2 divided by 1 is plus or minus 2. 3 divided by 1 is plus or minus 3. And 6 divided by 1 is plus or minus 6. Now, let's recall. To determine if any of these numbers are zeros, we can run it through synthetic division, and we must get a remainder of 0. Now, your highest exponent is 3. Going back up to the original problem, the degree of this polynomial is 3. Therefore, we should have 3 zeros. Okay? So, to start testing to see which one of these 3 are zeros, we must choose one of these numbers and run it through synthetic division. So I'm going to start with positive 1. If I start with positive 1, I will pull down my coefficients for descending order or synthetic division. I am in descending order, so I have 1, 2, -5, and -6. So what I'm trying to determine is which one of these is a 0. So I'm going to test 1 first. So let's pull down 1. 1 times 1 gives me 1. When I add, I get 3. Multiply and add. 1 times 3 is 3. When I add, I get -2. 1 times -2 is -2. When I add, I get -8. Therefore, -1 is not a 0. I know it's not a 0 because I didn't get a remainder of 0. Next, let's try -1. I'm going to try -1 in my box. I'm trying to find one of these numbers listed in my possible rational zeros to give me a remainder of 0. And then I will have 1 0. So using synthetic division again, pull down 1. -1 times 1 is -1. Add, I get 1. -1 times 1 is -1. Add, I get -6. What's -1 times -6? Positive 6. And what is my remainder? 0. So yes, -1 is a 0. So that's one of my final answers. Now, in order to find the remaining zeros, you must write out your answer here using these numbers as coefficients and constants. Now let's remember, the original problem was x cubed. So right here's x cubed. When you write out your answer, you must lower it down 1, x squared plus x minus 6. So now we will take each one of these, the x squared plus x minus 6, set it equal to 0. This is a quadratic equation. Let's factor x and x. Signs are different because I have negative on the back. Factors of 6, 1 and 6, 2 and 3. If signs are different, students, you're picking out the pair of numbers that subtract to give you -1. So I need -3, +2. Now, I made this work. If I went back and foiled, I would get what I started with. Now, set each one of those equal to 0. X minus 3 equals to 0. X plus 2 equals to 0. So let's add 3 to both sides. I get x equals to 3. Subtract 2 from both sides. I get x equals to -2. And we had already found the other 0 to be x equals negative 1 from when I ran it through synthetic division and got a remainder of 0. So I have found all of my zeros of this problem, negative 1, 3, and negative 2. So those would be my final answers when I am asked to find all the zeros of this problem.